sine and cosine have a domain of negative infinity to infinity. And you've noticed that you can plug in anything you want into sine and cosine, right? Because it keeps going around the circle, so there's no real limit as to what is allowed inside the two functions. Number two, sine and cosine have a range, and you notice that they peak at a specific value, right? -1, and is the lowest it ever goes, and 1 is the highest it ever goes. Okay. I would advise you to start making like a formula sheet for your exam, like here little by little. Whatever you use often in your homework, start putting that on a sheet. Stuff like all the properties, definitions, and then this type of stuff too. Number three, tangent has a domain of all real numbers. So similar to to cosine, sine and cosine, domain of all real numbers except odd multiples of pi over 2. Secant has a domain of all real numbers except odd multiples of pi over 2. I'm sorry, of pi, just pi. Sorry, I messed it up. I read the other one. I was writing this again. It should be secant has a domain of all real numbers except multiples of pi, because we know that. Let's see here. No, what am I talking about? I'm getting it all mixed up in my head. I'm very sorry. It was correct, because secant is what? 1 over cosine, right? So the problem would occur when you have pi over 2. So it was right. Odd multiples of pi over 2. I was thinking of cosecant, the next one. Cosecant. Okay. Cosecant has a domain of all real numbers except multiples of pi. All right. Number 6. Now the cotangent Cotangent has a domain of all real numbers except multiples of pi. Except, let's see, yes. Cotangent is technically what? Cosine over sine. So sine would be have issues at pi and 2 pi, 3 pi, 4 pi. Yeah. Cosecant would have issues same place because it's 1 over sine. Yeah, no, we're good. Let's double checking. Range. All right. Sine and cosine have a range of -1 to 1, 8, cosecant and secant and secant. Let me make a space there. It looks ugly. Cosecant and secant have a range of, this is a little weird, but I'm going to write it down here. -infinity. Brighten this up a little bit. To -1 bracket union 1 to infinity parentheses. Yes. Number 9. Tangent and cotangent have a range of -infinity to infinity. So let me look up what this homework looks like for 7.5. Make sure there's no. All right, so here are the properties for sine. These will be, we'll start with sine, then we'll do the cosine. Sine equals y equals sine x. There it is. All right, so first property, the domain, which we already mentioned in 7.5, is all real numbers. Number 2, I'm going to shorten this. The range is -1 to 1. Okay, 3. The sine function is odd. Let me zoom in a bit. Okay. Oh, that's right. I should mention the property of what it means to be odd graphically. So it's odd, and has symmetry. With respect to the origin. Okay. Next bullet point. Sine is periodic, meaning it repeats itself, right? With a period of 2 pi. Sine has x-intercepts at negative 2 pi, negative pi, 0, pi, 2 pi. Has a, I guess I should phrase it better. Sine has a maximum. Sine has a maximum at 1. Oh, share phrase maximum of 1. When x is equal to negative 3 pi over 2, negative pi over 2, oh, sorry, positive pi over 2. Five pi over 2. As you can see the pattern, right? It's like the odd multiples. Next one would be 9 pi. Anyway, I'll show you the graph soon. Sine has a minimum of 1 at, or I should say, when x is equal to pi over 2, 3 pi over 2, 7 pi over 2, 11 pi over 2, etc. Keeps going. All right. So those are the main properties of sine. So knowing all these pieces, you can technically graph them by hand, and I'll show you how, but you will not be required to. I will let you use that graphing app I've been using during the exams. Or
You
a
said
graphing
it's
calculator. What's up?
Oh, it says it's odd and has symmetry with respect to the, is it X or the Y origin?
The origin, the center.
Oh, the center. Yeah. Okay. Yeah, you're right. Okay.
The XY origin, I guess. They'd be
Gotcha.
both.
On the last bulletin, the point, the 3 pi, what are those last two? Is that 7 and 21?
Yeah, 7 pi over 2 and then 11 pi over 2.
Oh, 11. Okay, thank you.
All right, so I'll try to shorten it on the next one because it's the same stuff, but just changes little parts here. I'll show you. So properties of cosine function. Okay. Y equals cosine x. All right. So the first point will be the same. I put little quotes meaning it's the same thing as sine. So we don't have to write down the exact same thing. You know what I mean? So number 2, second little thing is the same thing. They have the same domain and range, which we wrote down during the last section. Does that make sense? Okay. The cosine function is an even function. This one has symmetry with respect to the y-axis. Okay. Period is 2 pi. And when I say period, I mean that's how long it takes for it to repeat. And I'll show you in just a moment. X-intercepts are negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, okay, max value of 1 at x equal to negative 2 pi, 0, 2 pi, 4 pi, 6 pi, and so on. Minimum value of 1 at x equal to negative pi, pi, 3 pi, 5 pi, and so forth. Okay, almost done with the definition stuff, and then I'll start showing you how to graph them. Here's a theorem. All right, so if this is technically omega, but I can't really draw very well. Looks like a W. So if omega is greater than 0, the amplitude and period of y equal a cosine of omega x, and y is equal to a sine of omega x are given. So if omega is greater than 0 and the amplitude and the period are given by this. So if this is true, then we have the amplitude amplitude equal to the absolute value of the A, period, was equal to, we also call it T, equal to 2 pi over omega. All right, finally we can start some examples. And this is the questions you're going to see on your homework. They're going to ask you, they're going to give you a function. They're going to say, okay, what is the amplitude? What is the period? And then they'll ask you to graph it on their little thingy. Okay, I'm going to zoom out here a little bit. Okay. This pen's failing me. So given y equal to negative 3 cosine of 3x, what is the amplitude? And period. So all you have to do, well, you can graph it, of course, but you see how if your generic cosine and sine are right here. So the A in front, you take the absolute value of the A, and that's your amplitude. Our A is negative 3. So absolute value of negative 3, right? Amplitude is equal to the absolute value of A, which is the absolute value of negative 3. So in other words, you just make it positive. That's it. So the number in front of the cosine is the amplitude. Period, we wrote right here, is 2 pi divided by omega. So the period is equal to 2 pi divided by, then you look at the number in front of the x, that is your omega. So it'd be 2 pi over 3. So I know we're just following a formula, but what does it mean, right? It's we need to graph it so you can see it. Okay. Let me close all this nonsense. All right, so y equals, first let's look at the original. Where am I? Here we go. So here's about pi over 2, right? We said there's a 0 at pi over 2, an x-intercept for cosine. And then we have another one over here, 3 pi over 2, right? Highlight these peaks and valleys. Oh man, let me zoom out a bit. Okay, so looking at our notes, we said there is a maximum for cosine when x is equal to 0, right? So at 0, the max is 1. See how that's the highest it ever gets. But then it does it again at 2 pi. And that's what we said earlier on our notes. The lowest it ever gets is -1. So it peaks and then dips, peaks over and over again. So this will be happening at pi, 3 pi, 5 pi, odd multiples of pi in both directions, positive and negative. But let's say it starts here. How long until it repeats? Right, what is the x value? So this is the x0. When do you see it repeat?
2 pi?
Yeah. And that's why they were saying that the period is 2 pi, because from here to there, it started over. And it's a periodic function, which is what we said earlier too. It keeps repeating forever, over and over again. So then the question becomes now is, do you remember back in college algebra how they would transform a function? They would have a parabola and then make it fatter, skinnier, bigger, whatever. So same thing. Is that idea is for all functions, not just polynomials. So if I put a 3 here, it creates an amplitude of 3. So now the peak is 3, right? The lowest is -3. So I change the domain. If I put a -3, do you remember what happens when you put a negative in front of a parabola?
Flips it.
Yeah, so same thing, same deal here. It's gonna flip. You see that? So it flipped it. Now, if I put a 3 inside, what do you think is gonna happen?
Make it wider?
I was going to say the other way.
Or
Right, so there's with the 3, without the 3. Looks like it was smashed, right? But the better way to think about it is this is affecting the period, meaning it's become faster. It's repeating sooner, right? You see this? Compared to before, it took a little bit to repeat, right? Now it's like repeating over and over again. So this has made the period get reduced by 3 from the original. Basically, it tripled the speed, meaning it finished 3 times faster, which is the same as saying I shortened the period by 3, a factor of 3. Does that make sense? So
In order, in order to make it wider, would you do x over 3?
Yeah, that would make it slower, right? Let's see if I can do it. Yeah, it looks much slower now, right? So it took a little longer to repeat. So now let me get rid of this 3 so we can compare it to the original. Originally, it repeated at 2 pi, right? Here's 3 pi. It still hasn't repeated, has it? Six pi. Repeats finally at 6 pi. So it's 3 times slower. So the period was 6 pi, right? Instead of 2 pi. But anyway, so same ideas as from college algebra, we're repeating them again with trig functions. So the number in front determines the amplitude. The number in here messes with the period. So going back to the paper here, that's what this is talking about. What is the amplitude? Well, it's 3. The period, well, it's this shortened it by 3. So all you have to do is take 2 pi and divide by 3. Whatever number is there, you divide by that. And that's it. Does it make sense what amplitude and period mean? Do you see visually what the domain and range are?
Yep.
Not too bad, right? I think it's a lot easier to just see the picture personally.
It's a lot of little rules that you gotta.
Yeah.
I'm not complaining.
No, it's all right. Some rules are more fun than others, I guess. But see how cosine is even, right? So you see the symmetry on the y-axis, right? Same thing here. Sine has symmetry with the origin, meaning if I flip it through the center, I would get this side, right? It's hard to visualize that, but imagine bending this over here. So there's a symmetry here. It's the same over here, but upside down, basically. Okay. Any questions on this first example and all this definition stuff?
Jack, how come when I put like in the calculator y equals cosine x, I'm just getting a straight line?
What calculator do you have?
84 TI 84 plus, the silver edition.
You need to change the window. Here, let me show you. Be easier if I showed you.
Like zooming in.
Yeah, I need to zoom in with the trig standard.
How much are those calculators?
I got it. Well,
what's
here's
that?
Is it an LCD like this one?
This one's a LCD.
I want the fancy one.
The fancy, there's newer. They're like really thin now, and they charge like a cell phone. No batteries required. These are all colored. Those are like 120 nowadays, around there somewhere. Maybe cheaper.
Really?
I would check a pawn shop first though.
I'm gonna do that.
My buddy said that there's a bunch on OfferUp. People trying to get rid of them. So that's another option.
Nice to know.
So if you graph it, so yours doesn't come out like this, right?
no.
So if it doesn't, you hit zoom and then press. See how there's different types of zooms? Hit 7. That's trig zoom.
Okay.
So
good.
now it looks a little bit better like the website.
Yeah. Okay, thank you.
If you want to trace the values, just hit trace and then toggle right and left, and you can see the X and Y on the bottom. You see that? Except they have it in decimals, meaning they don't have it as pi. They have it as 3.14, whatever.
Okay.
Okay. All right, let's see if there's any more examples worth doing.
What was the button you hit to see the min and the max again? Once you graph it, is that the table button?
I just hit trace, and you can toggle it around. You can move your cursor along the graph. See. Now, if you want the specific peak, you can hit second. Sorry, a little out of the screen here. Second, and then trace, and you can tell it to find minimums, zeros, etc. Assuming you need that. Okay. Alrighty. So yeah, the entire section in 7.6 is basically going to ask you to graph sine and cosine. I'm going to let you use your calculator or that website. I'm not going to force you to do it by hand. The only thing I expect you to be able to answer is what is the period? What is the amplitude? And what is the maximum minimum? So what you could do with your graph. Okay. 7. Let me look at 7.7. What was that? So 7.7 really is the same deal. Let me look at it. Actually, let me show you instead. So first, let me show you 7.6. That way I know the hell's in there. So I forget. Okay. So let's just go through it real quick. So they're gonna ask you questions like tangent, symmetry, with whatever. So that's more like, okay, what is the definition? There's not much stuff from the book. Secant. Let's see here. Find the intercepts. So here you can graph it and then just tell it what the intercept is. So nothing insane. Okay. Here you just need to find when is the y value -1. So again, you graph this function and you check on the graph itself and you find it. So as you can see, it's very repetitive. It's just getting you comfortable with what do they look like. And that's what matters. What I want from you to get out of 7.6 is what does each function look like, the 6 functions, and can you find the amplitude, periods, and I'm not going to make you memorize the domains, ranges, etc. I just expect you to have that handy when you take your test, like a formula sheet. Let's see, same type stuff.
I'm sorry, could you repeat what you just?
Yeah, so I don't expect you to have like all these properties memorized. I prefer you have that on a formula sheet. I just want you to have a basic idea of what each one looks like. The original cosine, the original sine, tangent, cosecant, secant. The original 6. If you know what they look like, then great.
Okay, no problem.
On this question, you graph it and choose the right one. So as you can see, it's all just graph the function over and over again. So I recommend using your calculator or the Desmos app. And I will make sure that Desmos is available during your exam. Okay. If you choose to use it, in case you don't have a fancy calculator. So 7.8 is, so that's 7.7, sorry. 7.6 is the same deal. I thought I was in 7.6, but I'm not. So 7.7 is just focused on secant, cosecant, tangent. 7.6 is cosine and sine. That's the only difference. So I'm going to skip 7.7 and move on to 7.8 because that one's a little more difficult. Okay. This is week 4. Yeah, we'll do that. So let's go over 7.8 and then we'll call it a day.
Cool.
And then on Thursday, I'll do exam review. And we'll talk about when you should take it.
Is the test going to be next week?
I'm basically going to open it tomorrow or Thursday. And you
Okay.
can take it anytime until I close it, which I need to choose a date. I have not decided. Okay, here we go. So for 7/8, this is the main thing I need you to know. Do you remember when we would shift functions around if we added a number or subtracted? There's a vertical shift and a horizontal shift back with parabolas. So it's going to be the same thing you've done before, but with cosine, sine, etc. But I'm going to cover it. I'm going to go over it briefly again in case you forgot. And I'll show you the visual because it's pretty easy once you see the picture. But since I'm not going to make you do it, since I'm not making you do it by hand, these sections will be very easy. When I say easy, I mean it could be harder by not letting you use a graphing tool. So number 1, y is equal to a sine of omega x minus phi plus beta. Actually, capital B. Beta is reserved for something else.
Omega x minus what?
Phi. The Greek letter phi. Let's spell like this.
Phi. Okay. Thank you.
Yeah, I don't expect you guys to know your Greek alphabet. Unless you're in a sorority or something. Or studied Greek stuff. Number 2, y is equal to a cosine omega x minus phi plus b. Precal likes to introduce a lot of Greek letters. And graduate level math, when you're working on your PhD, they start to use Greek letters. We kind of ran out of, we use Hebrew letters. We run out of Greek. It's kind of funny.
Are you working on your PhD?
No, not anymore. All right, amplitude is A, period. This stuff is
I bet
tough.
it's hard. I bet it's hard, huh?
Yeah, it was. It is very hard. It takes a lot of time, man. But it's worth it. It's worth it. I recommend you either do it really young or when you're older, but not in the middle.
What about like 28? Because you look pretty young.
Yeah, I mean, it depends really. Like if you just go straight from high school to a PhD, that's perfect. But if you start having a family and life gets hard, then I'd probably come back after your home life chills out. That's what most people do. Either you see a younger guy or a really older guy doing PhD. I never see something in the middle. Okay. So example 1. So y is equal to 3 sine of pi x plus 4 minus 5. So they're going to ask you, just let's write down everything that we know, right? What is the amplitude? Let's practice.
3.
3, right? Because you just take the absolute value of 3, which is just 3. What is the omega?
Pi?
Yeah, it's just pi. Okay, what is phi?
4.
Let's see. Well, check it out. It's kind of tricky, right? Negative phi, so it has to be the opposite. Since it's already positive, you would say minus 4. So just to remember, whatever you have in here, just flip it to the opposite sign. If it's already minus, then choose positive. If it's positive, choose minus for phi. That's the only weird one. The rest are normal. B is -5, right? I'll do the hard one for you. Okay. So once we write all that down, we should be able to find period, amplitude, phase shift, etc. So find. So I suggest when you do these homework problems, write all this down first and then go and use these formulas up here. Okay. Find the period, amplitude, which we already have, phase shift, of this graph. There we go.
Why get a PhD?
That's a good question. It really depends what you want to do. For some people, it's just some goal they want to achieve. For others, they just truly love the subject and they want to master it and become a researcher. Depending on which PhD, sometimes they do pay quite a bit for that kind of expertise. But 90% of them end up becoming professors in academia doing research. But they're hiring more and more masters and PhDs into industry, though, these days. Let's see here. All right, so where do you have amplitude, right? Okay. So A is 3. What is the period? T is 2 pi over omega, right?
Two?
Yeah, it looks like it, right? 2 pi over pi, which is 2. Yeah, nice. Phase shift. Is phi over omega. So phi is what?
-4
And divide by omega, which is
pi.
pi. So there is my phase shift. All right, so let's look at the homework. Make sure there's nothing I missed. I think that might be most of the questions. There will be some where you may have to factor something inside and then you do this step. But most of them are just like this. So there might be a couple that'll trip you up. That's part of practicing. Seven, eight. Yeah, here it is. There it is. All right, so this is the last section in chapter 7.
And this is the chapter that we're gonna be tested on, right?
This is the last section that you will be tested on. Yes.
On the problem that we just did, we don't do anything with the B, the -5.
No, I guess not in this one. If they asked us to graph it by hand, then you would need everything. But I'm not making you do that.
But we're going to graph it with these 3, the 2, and the -4? Or is this the answer right here?
If you were to graph it, I would just punch in the equation into the Desmos website just to make it easy.
Okay.
But the old school instructors will force you to do it by hand.
Can you show me how we would graph it in the
Yeah,
Well,
sure. Yeah, let's do it.
Okay.
So this is what what I recommend. You don't have to use this, but I recommend use this guy for your test. And I'm going to leave. So inside your exam questions, you'll have a link. You just click it and it'll open a tab for this. Because remember how we have Respondus lockdown? So it locks down the browser and it's recording you. But it will allow you to open this tab, and that's it. So when you do, just type in the equation y equals 3 sine of pi x, right? Plus 4 minus 5. There's my graph. That's it. Nothing else to do. So the 5, but let's go through what all these pieces did, right? So the 5 shifted it downward by 5 because it's a minus 5, right? So let's go piece by piece just to get a better grasp of what's going on here. Here is the original, right? So y equals, so if we add a 3, we said last time that it spikes the amplitude by 3, right? 3 times higher, 3 times lower. That's what the 3 did. Now, what did the pi x do? If we look at the original, I'm going to turn off the red one for now. If I look at the original, pi x, the blue one, and see how the period has changed, right? We said that the pi is the period. It is the coefficient of the x affects the period. So you can see it's pi times faster. Now on the inside though, I'm going to turn this one off. Now, but what does that minus or plus 4 do? Let's see. Plus 4 inside. Oops, my fat fingers. There we go. There we go. So the plus 4 shifted the graph. You see that? How it originally started here. Now it's starting over here. So looks like it's a phase shift. Oh, sorry, not a phase shift, a horizontal shift. If it's plus 4, usually that means a minus shift, so it's actually the other way, now that I think about it. So here's the beginning. The new beginning is over here for the green one. There it is. That makes more sense. So the original is the black. The plus 4 shifted it horizontally by minus 4. Do you remember doing that with parabolas?
No.
No, that's just for fun, right? Just to remind you real quick. Here's the original parabola. If you were to put x plus 4 inside the parabola, see how it shifted by 4?
Mhm.
That's what we're doing with the cos. This is what we did in college algebra. So we're doing the same stuff with sine,
Okay.
right? Now, if you were to put a 3, right, same deal. It's 3 times faster, so it's more narrow. A fraction would be fatter because it's 1/3 slower. So all these ideas are here.
Okay, thank you.
Does that make more sense? What each part does?
Yes.
Okay. I know the theory without a picture sometimes is difficult. Okay. Alrighty. Let me look at the homework and make sure I didn't miss anything because I don't want you to be stuck on some hard problems. You can see this, right?
Yep.
Okay. All right, 7.8. Let's see what the first few look like. It usually starts off with theory.
So we can only see this screen though, at that first screen though. We can't see anything when you go into it.
Oh, really? Let me see if I can fix that.
So I noticed you went from 7.5 to 7.8. Is 7.7 going to be prominent on the test or?
It's the same stuff as 7.6. It's just
Okay.
instead of sine and cosine, they do secant, cosecant, and tangent. I think it's the only difference.
Jack,
Uh,
for
mhm.
homework, sometimes we have like word problems.
Yeah, there's a few questions that I meant to delete. So if you run into a ridiculous word problem, please let me know.
Okay, but like
There's-
the test won't have stuff like that. It'll just kind of be.
They'll have
They-
basic word problems like that we've done together, not
Okay,
something
cool.
insane. The crazy
Yeah.
ones are supposed to be for homework, but if we didn't really go into too depth into too much depth, I feel like we should delete them.
Cool. Okay.
Just let me know. Every once in a while I forget one. But you can see this now, right? The
Yes.
homework.
Yes.
Okay. Alrighty. So this is just definition. Amplitude. This one's easy, right? What's the amplitude?
3.
3. Yeah. So same deal here. 6, right? They do ask for the period and phase shift, which is going to be the formulas I gave you. So let's go to that first one. So yeah, amplitude would be 3, right? Period would be the omega over 2 pi over omega. But doesn't seem too bad, right? I don't think. Let me see if there's any weird word problems in here before I let you guys go. Yeah, they're still asking about amplitude. So here they do the opposite. They give you the amplitude, period, and phase shift, and you got to fill in the blanks. So based on the formulas I gave you, you work backwards. Does that seem doable? I think that might be the only thing that seems difficult in here. These I would like to delete because these are funky questions. I'm going to delete those right now. So you're not going to see that on the test. So
Okay, cool.
okay, but yeah, you guys have any questions or concerns on 7.8?
Is the test one and done, or is it 2 tries, or?
It's one try, but I'm going to be grading your written work. So whatever, I don't really care what answer choices you choose. What matters
Gotcha,
is how good is your work and did you explain yourself? That way I can give you a ton of partial credit. It's not wrong, right or wrong.
And so we upload, is the work, are we uploading pictures of our work, or we write,
Yeah, you're going to scan every single question, show all your work. The more steps, the better. If you feel like there's not much to show, then that's up to you. But if you're wrong, then you lose a lot of points. But I recommend showing as much as you can, unless you think it's ridiculous. Like 2 + 2 is 4. I don't think that's necessary. Right.
Gotcha. Okay.
About how many questions are going to be on the test?
Let me see. Let me check. I'll check for you. Hold on.
Thank you.
I don't remember offhand. Okay, I deleted all the word problems except one, just so you can practice. Okay. Exam 1.
Will there be a review for homework?
Oh, well, what do you mean, like question, like to go over homework problems, or?
Sure.
Yeah, I'll probably do that on Thursday. We'll just spend the time reviewing for the test and answering homework questions.
Oh, I see.
There
Are we-
yes.
We going to be live, like, how do you say, like right now for the test? Or is it in our own time?
It's any time you choose, but it will be recording you when you start. And once you start, you have to finish it within that time.
Oh, it'll record us.
Right.
Okay, but it's not during class.
No.
Okay.
So I'll probably for sure review Thursday. I may review Tuesday. Haven't decided. There are 20 questions. The first first four are related to the partial fractions, the 12.5 stuff.
I have a quick question. This might seem weird. Can we listen to music while we're taking the test?
No, that's fine. I mean, as long as you're not talking to someone the entire time.
All right, cool.
Music's not a big deal.
Could you
First
finish the list you were about to say?
First for partial decomposition, and then
I'm sorry.
you said first four questions are partial decomposition.
Yeah, so the chapters of 12.5. So first four problems. I know people were struggling with that at the beginning, so I figured I'd give you a heads up and remind you what I said back then. Just setting them up is a lot of points. So if you're not able to solve them, the A, B, C, D, etc., at least set it up because you'll get a majority points at that way.
Okay.
Excuse me. Does that make sense?
Why were the partial fractions later in the book? Why are they 12.5?
They used to be done like at the end of the semester, and it caused a lot of problems. So we decided to throw it in with the easy test. The first test is the easiest one, and I think that was what they were thinking. At least that's my theory. I didn't make that decision.
It's gonna get a lot harder than this.
I don't know. Let me think about it. That's a good question. Let me look at the syllabus before I scare you. Let me see. It may get a little harder in certain chapters, like let's see. Like chapter 9 is all about formulas. So some people feel like that's the easiest one. Other people might not feel that way. Chapter 8 is all about identities and proving stuff, and some people really hate that, and they feel like chapter 8 is the hardest one. So it depends on what you're good at and what you like. My own personal opinion would be that chapter 7 is the easiest, 9 is the second easiest, 10 is about the same, maybe a little harder, and 8 is the hardest one. Test 2 is the hardest one. At least by how people, by looking at the grades and people's struggles.
You mentioned scanning, so we're writing this on scratch paper, right? Writing out our problems, and then I'm assuming, I know we're on Respondus. Are we scanning it with our phone, or how are we?
So
like,
once you finish the exam, so what I'm hoping is like you start question 1, you start solving it, show your detailed stuff as neat as possible, go to number 2, etc. You finish your test, you have 30 minutes to scan it and upload it in the next module that says written work or whatever. And once you do that, you're done.
Okay.
And are we scanning it using an app or?
Yeah, you can use whatever you like, app or a scanner. I know iPhone can scan with the Notes app. There was also what's it called, Cam Scanner or some other stuff.
Okay.
If you need help or you have questions about scanning, let me know. Let's see here. You guys have any other questions or concerns on 7.8 or the test stuff? We'll talk more about the test next time too, so we hadn't really got to it yet.
No more questions.
I guess I'll see you Thursday and we'll start reviewing and
I have a
practicing.
homework question.
All right.
I was trying to solve a.
What section was it?
This was Give me a second. It was over an answer and how to simplify it. It was it's like a radical question.
Oh, okay.
It's probably like a property that I don't know or something like that. But
What was it?
it was let me see. Give me a second. I'm not.
Okay.
Jack, speaking of which, like,
Mhm.
do we all, like for a radical, are all the answers, if it's radicals, have to be in that, or could we like make it in decimal or something?
Well, on the homework, it depends what they ask for. If they
Yeah.
say the word rounding, then yeah, sure, decimal is fine. But if they say exact answers only, then you need to use the square root stuff.
So on the test, would we have that option or not? Not.
I would prefer the square root.
Okay.
Let me see. Yeah, the square would be better. That way, you don't have to worry about messing up with the rounding, and everyone will be the same.
Gotcha.
But if it says rounding, then that's fine. It doesn't say assume exact.
Will the Desmos calculator be available throughout the test, or is it only specific questions?
Once you open it through one of the questions, it should stay open. So, yes, it'll be open. So basically, when you open question 1 or whatever, you'll see a link, or question 2 or whatever. Once you open it, it should stay open the entire time.
Hey, I have the question ready. Can I share my screen?
Sure. Let me turn it on for you. Go for it. Okay.
You can see it, right?
Yeah, I'm seeing, watching.
Okay, so for the secant, I had written, or I had gotten the answer. I believe it was.
Well, I don't see it anymore. All I see is the questions, like, which I don't know. You select
right.
that pop-up box.
Sorry. So for this answer, I had gotten 20 square root, not square root, or yeah, square root of 23 over 25. I was trying to figure out how to get this answer. I could not find out how.
So you had square root of 23?
Yeah, it was square root of 23 over 25.
And they have square root 6 over 2. Well, hold on here. Well, what is secant, first of all, right?
Secant?
It's 1 over cosine, right?
Yeah.
What did you get for cosine?
Cosine, give me a second.
You scroll up. Do you have it right there?
Oh, sorry. I was looking at my work. Oh, it's square root of 2 over 3.
Yeah, so you would just flip that guy over.
And you get square root of 6 over 2?
Yeah, so let's do it. So you had square root 3 over square root. No, sorry, square root 2 over 3, right? So let's go ahead and do that. I'm gonna stop your share real quick.
Sharing so I can see it.
Yeah, let's do it. Can you see?
Yeah.
There, this is 2. So what they did is rationalize, because we have a square root at the bottom. So if you multiply top and bottom by square root 3, you're going to get square root 6 on top. And then the bottom, you cancel the radical, giving you just a 3.
Wow. Okay.
So that was it.
You know how long I spent on that?
Okay, man, I've been there. I've been there many times.
Man. And I knew it was something like rationalizing. Ah,
Yeah, so they separated the root.
look at all this work. I like flipped it all, man. Thank you.
No, no worries. I mean, I remember writing like a 4-page problem and then realize line 2, page 1 is messed up, so it's all BS. I'm like, son of.
I hate when that happens.
Yeah, it sucks.
So how did you get from square root of 23 over 25 to square root of 2 over square root of 3?
I don't know where he got this. I think that was him going crazy, trying really hard.
It was me going crazy. Yeah, that was
But he all he had to do was use this piece, rationalize it to get this. I don't know what happened here.
So this is what I was doing. I put, for some reason, square root of 2 over 3 over 1.
Screw it 2. So you had it like, oh, okay. So you're saying you had like this one root, and then you flip that.
Yeah, I flipped it. Or no, I didn't. Yeah, I flipped it. Yeah.
So then you had 1 over this.
Exactly. Yeah. And then I tried rationalizing there. And yeah,
interesting.
It don't work.
So you had it like, but if you were to separate it.
Yeah, and then you multiply the reciprocals or the reciprocal.
Yeah, I think that messes it up. Because if I flip it over here,
that's crazy.
It'd be root 3 over root 2, which is not. Yeah, it wouldn't be this. Because they had root 6 over 3, right?
But see, I would put in the answer and it would tell me that it's not simplified. It was right, but it wasn't simplified.
Yeah, I don't know how this would become this though. I don't think it's. I don't think it. There's something. I think they were not being clear when they said, because they're implying that it was right and it's not. Right.
Right. Yeah.
That's what confused you.
Yeah, that was so easy.
And it happens.
Thanks, though.
Yeah, no problem. You guys have any other questions or concerns?
I have a if I know this is asking a lot because it's a pre-cal class, but I haven't been in math for a long time. I use this website because like the addition and stuff of square roots and radicals and stuff is like so old. Like I haven't done it in so long. I've been using this website, and maybe if you have a good part, you can let us use it too.
Probably not. But you can email it. I'll look at it and think about it.
Okay, thank you.
But I do expect you to do your own algebra.
Yeah, I figured.
But I understand how you feel because there's a lot of background that makes this more difficult than it needs to be.
Yeah.
I'm in the same boat as you.
But you're gonna have to brush up on the algebra a lot to catch up. Because if you go, how far are you gonna take calculus next, or do you?
I don't know. I just kind of took this for fun. So.
For fun. For fun. Good one.
Okay.
Sorry, I mean.
Do you have to take calculus to do the physics, or is it just the pre-cal that you need?
It depends what your major is and what kind of physics.
If I'm doing biology, I don't know if I have to have the calculus before I can take the regular physics class.
I think so, yeah.
Yeah.
I think, so the same problem's going to come up again. You're going to need algebra and calculus. So you need to learn it at some point.
Well, this is the prereq for physics, I think.
Algebra is just, it was a long time ago. I mean.
They might let you take it concurrently. Like if you sign up for Cal 1 and physics, they'll let you do it. but I don't think they will without doing that, unless it's basic physics. But the science physics, the physics for engineers and scientists, whatever it's called, university physics. I think that's the name. That needs Cal 1 or be taking Cal 1 at the same time, unless you get a waiver and they're cool with it.
I was told this one counted as a prereq for physics.
Oh, that's good, because I don't know how I would do it. I mean, I'm barely getting this, much less calculus.
I'm 80% sure that you need to sign up for both for university physics, but I'll double check.
Okay.
But either way, you'll need it for biology major at some point. All right, guys, if you have no other questions, you can head out, and I'll see you Thursday for some review.
Thanks, Jack. Bye, everybody.
Thanks.
Bye. Thank
See you
you.
later.
Yes, thank you.